Hey everyone, welcome to All About Python. In this three-part course, you shall learn about basic Python syntax, Python data structures, NumPy, and pandas. All you need to know before learning about machine learning and TensorFlow. In the previous video, we had covered the various data structures of Python programming language, which entails tuples, lists, and dictionaries. We had also covered the concept of functions in Python. In this third part, we'll delve into two powerful libraries for data manipulation and analysis in Python, NumPy and Pandas. But before we begin, let's make sure we have the necessary tools installed. To follow along with this tutorial, we recommend using Google Colab, a free online coding environment that provides the necessary packages and resources for data analysis. Here's how you can install and set up Google Colab on your device. We have Archishman Ray, our internal mentor, to show you the process of installing Google Colab.
So hello everyone. I just got an information that some of the people doesn't know what is a Google Colab notebook. So I'm just going through it and what is it about. So basically, Google Colab is another piece of notebook like Jupyter notebook. It is basically used in when writing codes, Python code or R code. And what it does basically is that the code you're running doesn't use your local server's configuration. That means if you have a 8 GB RAM, it doesn't use the 8 GB RAM. Rather, it uses the RAM given by the Google server. And I guess the RAM given is 12 GB RAM. Not only it gives you the RAM, but it also gives you a hard disk of 107 GB at TPU. And also it gives you a graphics card. Like it also gives you a GPU RAM. So it's a pretty amazing tool that is given by the Google and to run your Python codes or machine learning codes or the different computer vision codes if you want to run. So let's dive into it and learn how to install it. So basically first just create a particular folder or you can do it anywhere also. I've just created a particular folder and just right click over there, click on more and tap on connect more apps. A pop-up window will open. Let's wait for it. Yeah, it's open. Right here, Google Colab. Okay, I guess it's Colab. Yep, Collaboratory. You get it. Just click on the first thing. I guess it's one thing only, and click on install. Okay, so that's my account. I'm just signing into it. Yep, pretty much just done. Okay, cool. It's basically working on it as you've seen over here. I'll just leave for a bit time. Yeah, it has appeared. So after you did the following steps, just click on more and you will see over here the Google Collaboratory has successfully appeared. Just click on the thing and congrats, you have successfully installed Google Colab. So yeah, so we get into it and here you can rename your file numpy. For instance, I'm writing it numpy and here we'll be doing our code.
Now that we have Google Colab set up, let's dive into NumPy. NumPy is a fundamental library for numerical computing in Python. It provides support for large, multidimensional arrays and a collection of mathematical functions to operate on these arrays efficiently. Let's look at how to work with NumPy.
So hello everyone. In the previous section, we did cover up about like what is NumPy, numerical Python, and why we use NumPy. In this section, we are going to cover up why is NumPy faster than list and the remaining code part. So let's get started. Now, why is NumPy faster than list? So there are mainly two main reasons. One of them is that NumPy arrays are stored in contiguous memory. Now this means that the elements of an array are stored next to each other in the memory, which makes it very efficient to access them. Python lists, on the other hand, are not stored in contiguous memory, which makes accessing their elements slower. So let's take an example. So let's take an analogy of a toy box and a puzzle box. A toy box is like a list because it can store different kinds of toys such as cars, dolls, balls, etc. A puzzle box is like a NumPy array because it can only store pieces of the same puzzle. Now, if you want to play with a toy piece from the toy box, you have to search through the whole box until you find the one you want. This takes time and effort. Now, if you want to play with a piece from the puzzle box, you can easily find it by its shape and color. This is faster and easier. Similarly, if you want to do something with a value from a list, you have to access it by its index or position in the list. This takes time and memory. If you want to do something with a value from a NumPy array, you can access it by its data type and vectorized operation. Now, about vectorized operation, we'll learn in a later section. So this is like faster and more efficient. I guess it is pretty much clear to you. But if it's not, obviously comment down and raise question during the bootcamp sessions. Okay. Now on the second part, NumPy array are optimized for speed. Well, the NumPy contains a number of functions that are specifically designed to be fast. These functions are often written in C and C++. Now, as we know, C and C++ are like one of the most fastest language we got. So yeah, it increases the efficiency of that particular library. And Python lists, on the other hand, are not optimized for the speed, as we know. So without further ado, let's get started with the code. Like, I know you guys are much awaited for this thing. But before starting, remember to connect it, okay, to the collab. So it will take some time to connect it with the server, like the Google Cloud server, okay. Because we are obviously working on the cloud server. They are giving us the resources, and also you can check the resource. Like, I will show you what are the resources we got. So from here you can view your resources. So here it's saying you have got 12 GB of RAM and a disk of 107 GB. Okay, right now you're using 24 GB and 0.8 RAM. Okay, you can change your resource setting with GPU from change runtime, and you can go here and click GPU, you will get it. Okay, so yeah, but right now we don't need it, so we're gonna stick with this thing only. Okay, anyways, let's get started. So people who are using Jupyter Notebook do use this command to install NumPy. As I'm using Colab, it is pretty much pre-installed, so I'm just gonna run it. And if I run this command, you will see a code. Let me show you the code first. So here it's saying requirement already satisfied, NumPy in this location, in this path. That means NumPy is already installed in this thing. So yeah. Now let's create NumPy arrays. Okay. So here we have 4 variables. Let's go with the first one. Now data. What data is doing is creating a NumPy array with random values of shape 2, 3, and 4. Now let's understand what is this shape thing. I guess it is taught you in the list part, but if it is not covered up, no issues. I'm just showing you right now. Okay, but let's first print the data thing with shape 2, 3, 4. By taking that example, it will be much clearer. Okay, so let's go ahead. Oh, my bad, sorry. I just forgot to run this particular cell. And let's go ahead with this thing. Okay, we got a NumPy array, okay, with the shape 2, 3, 4. Now, what is this shape thing? For example, if I am not taking this 3, 4, like for now you forget this 3, 4 did existed. Okay, so if we make this thing data is equal to np.random.rand2, what output it will give? It will give us a one-dimensional array containing 2 elements. Okay, let's run it and see if I'm right or wrong. Yup, it's giving us one-dimensional array of 2 elements. Now what I want, in particular this one element, I want an array containing 3 elements. In this one particular element, I want another array containing 3 elements. So what I do, I make it a 3-dimensional array. Sorry, 2-dimensional array. Okay. Now I'm just doing this thing and let's see what happens. So you got an array which got like 1-dimensional array containing 2 elements, and 2-dimensional array, if you see, there are like 3 elements in the first element and 3 elements in the second element. Likewise, if we add 4, which makes it 3-dimensional array, and as you can see, it gives a random value with the shape of 2 comma 3 comma 4. I hope it's pretty much clear. Okay, now what is zeros, full, and ones? Now np.zeros gives you a 3-dimensional array, 2 comma 2 comma 2, 3-dimensional array consisting all of zeros. Okay, now if I check out with zeros, zeros, so it's giving you array, okay, of consisting all of zeros. Now what will full do? Full will it will take it will make a 3-dimensional array, as we have given 2 comma 2 comma 2, 3-dimensional array, and fill it with 7. What full does is it fills your array with the particular number you have given. Okay, so if I give full over here, you can see it is giving us a 3-dimensional array consisting all of 7, of all elements of 7 numbers. Now if I give over here 8, it will give us all 8 numbers. Okay, now that's it pretty much. Now I left the ones to you guys. I guess you guys can do it, so I'm not explaining this one. Okay, just run the code and execute it, or just comment down what you guys are guessing it. Okay, now let's come over to this part. Now obviously we will make arrays, customized arrays. Like we won't always stick around, I need always 8, or I will need always 10, or always 7, or always zeros, or always random values. We need customized arrays, right? So over here, how will we use NumPy? So the particular syntax is np.array. Now you will ask, why np? Okay, now you guys don't think NumPy is always treated as NumPy. It's an alias. Now what is alias? Here import NumPy as np. Now if I remove this as import NumPy, now this code won't work. Okay, see, it will generate UI error. Okay, excuse me, this thing. Yeah. So numpy.array. Okay, over here you're creating this thing, and numpy.array will be the stuff. Okay, now if you write over here np, okay, let's see if it's working or not. So over here, this np won't work. You know why? Because I have written over here import NumPy. Now import NumPy, if I am going to execute this particular thing, it will generate you error. Why so? Okay, now in the previous thing I used import NumPy as np. Okay, that's why it is using np as an alias. Now what is an alias, you say? So you have a name, particular Raj. Okay, now in your home, you have a particular name, for example, let's take Archishman. Okay, Archishman. Okay, so someone will call me Archie, someone will call me with my Instagram name Mochoy or something else. Okay, so that's an alias. That means what? Import Archishman as Archie, because many people are there, I won't spell the big name, so people are a bit lazy with writing all the NumPy thing. So we use alias as np. Np is the common thing we use. You can write here as np or nd or ny, it's up to you guys. Okay, but I'm using the generic thing, so as np. So let's execute it, and congrats, it's working. So now we have created an np.array. So np or NumPy or the particular alias you are using, that will be the syntax. Dot array, the syntax, and within the bracket you have to mention your array. Okay, right now we are creating 2 comma 4 dimensional array. That's 1 comma 2 comma 3 comma 4 and 1 comma 2 comma 3 comma 4. So we're creating a 2 comma 4 dimensional array, 2 comma 4 shape of array. Sorry, my bad. It's a 2-dimensional array. I just got carried away. Anyways, it's a 2-dimensional array with the shape of 2 comma 4. Okay, now let's check the for checking an array type. Okay, we use type in bracket array, so it gives you the type of the variable which you are using. Okay, if we use like a equal to 1 and give and see the type of a, it will show you int. That means it is an integer type. Likewise, we're seeing here the type of the array and it is showing us that it's the numpy array. Okay. So now let's go into the later part of the section. Let's read. Okay. Now what read does in the read section, what we are seeing, we are taking three variables: shape, size, and type. The shape stores the shape of the array. The size stores the size of the array, and types stores the particular elements type. Okay, like the elements, the like in the array, the all the elements are contained in which type. For example, an element is in int, or the element is in float, or the element is in like what data type it is in. So it contains that. Okay. Now, basically, if you remember or recall, I have created a random array, okay, which is 2 comma 3 comma 4. Okay, you can see I have created a random array of 2 comma 3 comma 4. What that means? I have created a 2 one-dimensional array. Okay, 2 elements of 1D, 3 of 2D. You can see 1 and 2 and 3. Same goes here. And how many? 4 of each elements, 1 2 3 4. You can see, so the shape should return what? 2 comma 3 comma 4. If I write over here shape, it should return 2 comma 3 comma 4. So it's the shape of the array. What is the size? The number of elements stored, like the number of elements that is contained in the data array. Okay, so what are the number of elements that are contained in the data array? Like it can be defined by a simple formula, or simple, it has a formula, not simple logic. Okay, that's like 2 into 3 into 4. Obviously, like 2 into 3 into 4, if you see, you can get the number of elements present in the array. So basically that is returning the size of the array, the number of elements contained in it. Okay, and notice types, data.types do. Now over here I want to specify one thing. Don't get confused with type in bracket data and data.types. Data.types, what it return, like let me print the types. Like data.dtypes return the like these are all in the float. Okay, the data types of each elements are in float. So basically the data.dtypes return the each elements data type. What are the each elements data type? It is in float. Okay, not what type dot like type in bracket data returns. It returns the whole, okay, the whole type of that particular variable. So that is numpy nd array. Okay, it's a numpy nd array because what is data? Data is the array. What array? Numpy array. Okay, now over if I give over here size, sorry, yep, you can see it is an integer because what I'm returning 24 now, so it's an integer. So that's the thing. So don't get confused between these two types. Data.dtype give you the type of each element present in an array, and like type in bracket the variable name gives you the type of the variable. Okay, so this is a basic thing. Now let's come into slicing part. In slicing, what we are doing, that we are creating an variable ARR where we are storing data in square bracket 0. What data in square bracket 0 will do? Any guesses? Just get a guess. Okay, so basically slicing is nothing but taking out a particular element or particular batch of elements from a particular array. Okay, so it should return. So let's see. First, let's compile. Now you can see what's returning. It's returning the first element of 1D array. So what's the first element of the 1D array? This is the first element. So it's returning that only because data is 0. I guess you guys have done about arrays and the position about it. So this is in 1D, the position is 0. The 0th position contains this in the 1D. See, the 0th position. It's the one is the first position. This is the 0th position. This one. Okay. Now likewise in slicer, what it does, like now it's going to 2D part. So what it is doing from the first element, like from the first dimensions first element, like from this element, give me those elements which are starting from 0 till 2. What does till 2 means? like written all the elements before the 2. What that means? 0 and 1. So what it will return? So slicer, let's see, slicer, you can see over here it is returning the 2 elements, this one and this one. It's the returning from 0th position of the 1D, like the first dimension. Give me 2 elements from the second D, that is from 0 to 2. That means 0 and 1. When it's 2 2, that means it will give you all the position, like the starting position. If this is the starting position, start to end, then it will return all the elements from the position start to end minus 1. Okay, so it is giving you all the elements till here, means it is returning 0 1, but not the 12th element. Okay, so it's a gone here. Now reverse data minus 1. Now what is minus 1? Minus 1 is pretty much simple, like it is a 0th element, this is the first element. Okay, and minus 1 is before 0 there is nothing, so what it does, it goes back over here. Okay, means it is going like 0 in before 0 there is nothing now. So before 0, what minus 1 means, it will be going back, like wrapping it, you know about wraps. So it is going again the back thing. Okay, so basically 0th element means from here it goes again to the last element. Like if the first, like from minus 1 it goes to the last element. Now second last element will be minus 2, the third last element will be minus 3. Okay, so that is minus 1. So what it should return, it should return this thing. Now let's like see it. Okay, in action, reverse, and yeah, you see 0.7 here, you got the value. Okay, now you can make custom array, you can play with it, so it will be more clear to you guys. Okay, now what is single level? Single level is returning like the over here, what is doing, it is saying give me the particular element from the first dimension's first position, from the second dimension's first position. That means from here give me in 0th row, like in the 0th position of first first dimension, in that the 0th position of the second dimension, in that the 0th position of the third dimension. It should return 0.78540 and something like that. So let's see single level, sorry, single val level. So it is returning that. Okay, you can see it. Okay, so that's it. Now pretty much it. Now if like I did something, so just pardon me this part. Okay, now let's update, like playing in the update part. Okay, so in the update section, what we are seeing, we are creating two lists, list 1 and list 2, with random values of like shape 10. Okay, and I'm just showing you the particular, like what is the array. So it is creating 1D array with containing 10 elements. Okay, like sorry, I guess I said shape 10, so my bad. It is creating a shape like array containing like 10 elements. Okay, so yeah, it is shape 10, but it is one dimensional array. Okay, because if I give over a comma 2, then it will create me say a 2-dimensional array. Okay, of random values. See, you can see. So but I don't need one right now, so I just need only 1 dimension right now, so to get the things in better motion. Okay, now let's do the basic maths over here. So addition with the np.add list 1 plus list 2, list 1 comma list 2 means like np.add, so list 1 plus list 2. np.subtract will do list 1 minus list 2. np.divide will do list 1 like divided by list 2, and np.multiply will do list 1 into like list 2. Okay, and np.dot. So now let's come to the update section, and it is the last part of the NumPy thing. Okay, so we are creating here two variables, list 1 and list 2, having shape of 10, which means like we are creating 1-dimensional array having like 10 elements in it. Okay, in both the list. Okay, to see the operations we can do with the list or the NumPy the thing. Okay, now we can see, just for an example I'm showing you. So in list 2 you can see there are 10 elements, 1 2 3 4 5 and 5 to 10. Okay, so we have 10 elements over here. Now let's start with the basic math operations, like adding two lists. So we are with add, like np.add function, giving you the list 1 and list 2. You can see like we can add two lists, list 1 and list 2. Now if you see, if I print add, it just gives you the value, which by adding it comes up. Okay, by subtract we will be getting the subtracted value, by dividing we'll be getting the divided value. Remember, it's like this. Okay, list 1 minus list 2. Okay, list 1 plus list 2. Here over list 1 divided by list 2. Okay, so it is basically what it is performing. Okay, so nothing else to it, like nothing much to it, just execute it and play. Sorry, I just wrote here much without writing much. Excuse me for that. Anyways, you can see over here it is doing a multiply value. Okay, there's another particular thing like np.dot. I'm not covering it, but it basically calculates the dot product. Many of you, like, because you guys are from science background, I believe, so you guys know about what is a dot product. Okay, so np.dot basically calculates the dot product of the two array. You can see it over here, np.dot list 1 comma list 2, and it calculates the dot product of the array, which is this particular value. Okay, now let's go into the stat particular functions. Now sqrt will return the square root of 25 and put sqrt. Now you can see sqrt, yeah. So it's written 5, obviously we know. Like that, abstract will return 2 because it's minus 2, so it's returning 2 right now. Okay, likewise if you go for power, it will return the 2 into 7, like 2 to the power 7 rather, sorry, my bad, 2 to the power 7. For log, it will return the log of the 25. For exponent, it will return 2 comma 3 is exponent. From min, it will return the minimum from the list. Now it is interesting, like you are just writing it and you're finding the minimum from the list. Like you don't need to have a search operation, it's just finding it for you. You just don't need to have to write a class or a particular function to find it. Just write here np.min and it just find it for you. Okay, so you guys got the min, then likewise you will get the max also. Okay, from the list 1. Okay, excuse me a bit, max. Basically what it did, okay, in previous thing I just show you what it did. Basically it is just saying it is a function max. A function named max is already created in numpy, so it is just showing you that there is a function named max. Okay, so it will be like max this thing, so it is returning you 0.97, which is the max value from the list 1. Okay, now again if we assign like this element 700, we can do like this. Now if you see you get this part, but it is in float, that's why it is doing like this. You can see plus 02, you can see that means it is plus, like if you know about expressions, so you will get it. It is a 700 plus 02. Okay, so I guess you get pretty much it. Now data.sort, we are just sorting the data.sort, we just sort the datas in the manner, I guess it's in ascending manner. So it is sorting in like from smallest to biggest. So yeah, that's all about in NumPy. We'll be covering the pandas in the later section. Okay, so nice. So thank you. Just get it covered up and just play around with it. And there is I will give you the documentation too. Go and visit there. You will learn many more ideas also, many more concepts regarding NumPy. Just have a look in it. Thank you.
Alongside NumPy, we have Pandas, which is a powerful library for data manipulation and analysis. It provides data structures like data frames and series, which allow us to handle structured data efficiently. Pandas allow a wider range of functionalities for reading, writing, filtering, transforming, and visualizing data. Let's look at how to work with Pandas.
So in this section, we are going to cover up the pandas. Okay. Now, why we need pandas and what is the use of the pandas? Okay. So doing any machine learning, like fitting a particular data set into any machine learning model, we need to first pre-process the data. Okay, the data which is given, it is in raw format. Now we have to see what are the loopholes in it, and we have to pre-process it. Generally, the term given to it is known as exploratory data analysis, or the EDA. Okay, and the best tool or best library which is used is pandas. So let's just stop gossiping and just get into it. Okay, now first we need to import the pandas. Okay, just give me a sec. So let's get into it. Now first let's import the pandas, but before importing the pandas, import any dataset whichever you want. You can get any dataset from Kaggle. Go to Kaggle and just download some random dataset and perform the EDA on your notebook. Okay, now I have just taken out the housing dataset from Kaggle. Okay, now let's just import the pandas first. I have already imported it. Now to read a particular dataset. Now as my dataset is in CSV format, so I am like reading it using read CSV. Okay. For HTML there's another read HTML, and for Word there is, I guess, I forgot that thing. Okay, I'll check it and see, or I will mention it in the notebook itself. So for like reading CSV files, you need to write pd.readcsv and the file path. Right now the file path is copy path. Over here you can just copy the path and I will just paste it. Okay, so it's working still. Now as because it is in the same directory, so if I just give this housing.csv, it will also work. Okay, so now for reading the top 5 rows from our CSV file, we need to do df.read and give the number 5. If you want to read 10 rows, then we can give 10. Okay, now I'm just writing 5. If you want 10 rows, then we can just write df.head in bracket 10. To read the bottom 5 rows or to bottom 10 rows, as you wish. Okay, bottom n rows, just it is df.tell in bracket n, or the number which you want to mention. So here I have given 5. So it's giving us the last 5 data. Okay. Now to see what are the columns present, because certain times like you won't get these things. Okay, so to see what are the columns we have, we just give df.columns, because it happens now there are like huge amount of data set, so there are huge amount of features, so it is in a better way to like look into it. So df.columns, it like returns in an array format and returns the name of every column present here. Okay, now df.dtypes says you like what are the data types of each of the column. So just let's run it and you can see. So the price data type is integer, the areas data type is integer. Okay, now the main road, it is an object. Okay, because it is in string format, so Python takes it as an object. Okay, now what does df.describe do? Df.describe basically summarizes all the statistics of like int or float columns. Okay, so let's just df.describe it. Now what we can see that the all the integer columns and the float columns, over here we have only the integer columns, but it considers also the float columns. So all the integer columns and the float columns, it gives you a statistic summary, like summary of a statistics. Okay, like it says count, it gives you the like standard deviation or the minimum, it gives you the maximum. Okay, so it is it. Now the common question what you will get is that, okay, I can get integer, I can get float, but how can I get an object? Like how can I get a statistic information of an object? For that, there's a simple piece of code that you just have to write include is equal to object. That's it. Okay, and then you will get the statistics of the object columns as well. Okay, now to grab a particular single row, you just have to give df dot the column name. Over here I've given price, you can give main road also, just the column name. Okay, now you'll see it is given like it is giving the columns, okay, it is giving you the only the main road column. Now if you give the guest room, so it will again give you the guest room column. Okay, now how to take more than one column? Just get df like the data frame, because we have like it's we are storing this in df, the data frame. Okay, now just give it like where it was. Just give it the all the column names, price, main road, basement. Okay, as it is in 2D, so we have to give like two square brackets. Now you can see like it is giving you a data frame which have price, main road, and basement in it. Okay, now how can you check what are the unique values in a particular column? Like you have to check now, like if there is a unique, how many unique values are there or not. So for that reason, just give it df dot the column name dot unique. You will get all the unique values in that particular column. For in this scenario, I have given the stories. Okay, stories. This particular column I'm sending. Now let's see what is the output I'm getting. I'm getting 3421. Means from the particular data set, from particular like this syntax, we can identify, okay, there are maximum of 4 story building and there's a minimum of 1 story building. Okay, we have this much of variations, so we can get all the unique values easily. Now sometimes what happens is in a particular data set there are many null values. I have to check for the null values. Okay, now to check for the null values, df dot is null is dot sum gives you all the like columns. It says that if any column contains null value or not. In my case, there are no null values. Okay, it gives you all the summation of the null values. If there are 2 null values, if it says you there are 2 null values, if there is a 3 null value in price, so it will say there are 3 null values in price. And if you get a null value, so just use this thing df dot drop in place is equal to true. It will drop all the null like null rows. Okay, and it will update the data frame. Okay, so now you can check it again by running this particular command again, and you will see there are no null values present. Okay, now what drop column does basically, now for example if you have 3 rows, okay, and now you need only 2 rows to send into a particular machine learning algorithm. Okay, so what you need to do, like just drop, like you have 3 rows now and you want to send 2 particular columns, so you need to drop one particular column. Nothing, just mention the column name and access is equal to 1. Access is equal to 1. Why? Because we are dropping columns. When we will be dropping rows, we will be using access is equal to 0. Okay, so just df is equal df dot drop this thing, and you will get like the bedroom is dropped. Now if I want to drop the bathrooms, you can see bathrooms is dropped. Okay, so likewise you can just get it. Okay, now if I get this thing and just store it over here, it will be permanently deleted. Okay, now if you again want to drop, it will say you there are no column exist. Okay, there is no such column bedroom exist because it has already dropped and we have saved that drop the data frame from which the bedroom was dropped into our like we're reinitializing it into df. Okay, so that's why it is not getting the bedroom again. Okay, now if you want to see df, see the bedrooms has been dropped, there's no bedroom. Okay, now for creating a new particular column, like you can perform arithmetic like operations in it. Okay, now over here I have created a new particular column. It is a column name price by area. Okay, and over here what I'm doing, I'm saying I want to like divide the price column by area. So we have to do like give df the column name divided by df the area, like the column name again, like the column 1 which you want to divide and the column 2 which you want to divide. Okay, so you can give over here plus also, you can give over here divide also, it's up to you. Right now I'm just giving over here divide, and it is creating me a new column with price by area. You can see it is creating a new column. Over here there was no such column price by area, but it is creating a new column for me price by area by just dividing the price column and area column. Now what happens, certain times you have to like like export the CSV file. Means there is a huge data set and you have shorted down into a particular data set because you want to see that your machine learning algorithm is working it on it not. Then you send the full data set. For that reason, you have to like shorten up the data set and then send it into the machine learning models. See the code is running or not, running it in or not, and then you send the actual CSV file. So for that reason, you have to when you short down your CSV file, you need to export your CSV file. So just write down your file name by which you want to export. Okay, and just write df.2csv output.csv and it will just export the CSV file. Now you can see over here a CSV file has been created. Now you can just save the file from here, download, okay, and it will be saved in a local desktop, okay. And for deleting the data frame, it is del df. Yeah, that's all for this. Thank you.
In conclusion, in this video, we covered the concepts of NumPy and Pandas. Understanding these fundamental concepts will give you a strong foundation for learning about machine learning and TensorFlow, which we are in our ongoing bootcamp, which is being organized by Skepsis and GDSC SNU. Register now if you haven't already. Link is in the description. With this, we come to the end of All About Python. We hope you found this course informative and engaging. Hope you enjoyed it, and let's hope to see you in the Machine Learning and TensorFlow Bootcamp.